Have you ever watched a giant aircraft carrier glide through wild ocean waves and wondered, how on earth does that thing not tip over? A floating city over 1,000 feet long, weighing more than 100,000 tons. Yet it stays steady enough for fighter jets to take off and land in the middle of a storm. It almost feels impossible, but it isn't magic, it's engineering. Aircraft carriers are masterpieces of design. They don't just float, they balance perfectly. Even with hundreds of crew, tons of fuel, and entire squadrons of aircraft moving around on deck, they remain rock solid. So how do engineers make that happen? It begins deep below the surface. Before we continue, if you're really interested in these topics, make sure to like and subscribe. It helps us grow and lets us bring you more great stories, reviews, and hunting insights. With the hull a wide, carefully curved structure built for both strength and buoyancy. Naval architects spend years simulating how every curve reacts to waves, turns, and pressure. Before a single piece of steel is welded, the ship's balance is calculated down to the smallest bolt. At the core of it all are two invisible forces, gravity and buoyancy. The center of gravity is where the ship's weight pulls downward, and the center of buoyancy is where the water pushes upward. The secret is to keep the center of gravity below the center of buoyancy. So no matter how rough the ocean gets, the carrier always rights itself. That's why heavy machinery, armor, and fuel tanks are placed low inside the hull, while lighter structures like the tower and flight deck rise above. But the ocean is unpredictable. If the ship starts to lean or list, engineers use ballast tanks, massive chambers that can fill or drain seawater in seconds. By shifting thousands of tons of water, they can instantly rebalance the entire vessel. Even with perfect design, waves can still cause rolling and pitching. That's where sheer size becomes the ultimate stabilizer. A carrier's enormous weight and width naturally resist movement. Some ships use stabilizer fins or keels to fight rolling, but U.S. carriers often don't need them. Their scale alone keeps them steady. Every single element, every bulkhead, every deck, every engine affects the ship's stability. That's why engineers follow a process called the design spiral. Design, test, redesign, refine, over and over, until the ship behaves exactly as planned, in calm seas and in chaos alike. And it doesn't stop once the carrier is built. During missions, the ship's balance is constantly monitored by sensors and computers. When aircraft take off, land, or are moved below deck, systems automatically adjust ballast levels to keep everything perfectly level. So the next time you see an aircraft carrier cutting through the waves, remember that balance isn't luck. It's the result of brilliant minds, precise design, and millions of calculations working in harmony with the laws of physics. But beyond all that, science and steel, lies something more human. Because when you think about it, an aircraft carrier isn't just a machine. It's a moving city, a symbol of what people can build when they work together. Inside those metal walls, thousands of sailors live, eat, sleep, and operate like one heartbeat. Every action, every motion, every command on board, it all depends on trust and precision. And that balance between man and machine is just as vital as the balance between gravity and buoyancy. Walk inside one of these ships, and it feels like another world. Long corridors stretch endlessly, echoing with footsteps and the hum of turbines. Somewhere deep below, nuclear reactors quietly generate enough power to light a small town. On the hangar deck, engineers and mechanics move in perfect rhythm, preparing aircraft that will soon roar into the sky. And above them, on the flight deck, pilots wait for their launch, staring out over an ocean that could swallow everything in an instant. Yet despite all that chaos and movement, the ship doesn't waver. It doesn't tilt. It doesn't break rhythm. Because every piece of it, from the bolts in its hull to the data in its computers, was built with one goal in mind: stability. And that stability isn't just physical, it's psychological. For the people living on board, the carrier's steadiness is a constant reminder. No matter how wild the storm gets, they are part of something stronger than the sea. That sense of security, of trust in the ship beneath them, is what allows them to launch jets into darkness, to carry out missions halfway across the globe, and to come home safely. Now, imagine this. The ocean is raging. The sky is black. Waves slam against the bow. The entire horizon disappears under walls of water. But inside, the command center calm. Lights glow softly. Instruments hum. And the carrier keeps pushing forward, steady as ever. That's the beauty of design. Meeting discipline. Chaos outside. Order within. To maintain that order, engineers rely on a constant flow of data. Hundreds of sensors monitor water levels, pressure points, and weight distribution. If something shifts, if a jet lands hard, if a fuel tank empties, the computers instantly react, pumping water from one ballast tank to another. It's like the ship has a nervous system, feeling every change, correcting it, adapting in real time, every second, every wave, every storm. And yet, for all its sophistication, the principles are ancient. Archimedes figured out buoyancy over 2,000 years ago. The science hasn't changed, only the scale has. What's evolved is our ability to perfect those laws, to push them to their limits, and still stay afloat. Because in the end, even the largest warship in the world must obey the same laws of nature as a tiny wooden raft. That's what makes it so fascinating. That something so immense, so heavy, can still be ruled by invisible forces we can't see. No matter how advanced the carrier becomes, it still answers to the same simple truth. You stay balanced or you sink. But balance isn't just about physics, it's philosophy. It's a reminder that even the strongest things depend on equilibrium. Too much weight in one place and everything falters. Too much ambition without caution and it all collapses. And maybe that's why these ships resonate so deeply with us. Because they're not just about war or power, they're about harmony, about control and humility coexisting. Think about how much coordination goes into a single launch. A fighter jet lines up on the catapult. Crewmen in color-coded uniforms move like clockwork. Signaling, loading, fueling, checking. Steam erupts. Engines scream. Then, in a flash, the jet blasts off the deck and disappears into the sky. Every person, every system, every ounce of that ship works together to make that one moment possible. One mistake, one imbalance, and it could all go wrong, but it doesn't, because balance is everything. And here's something few realize. When aircraft land, the ship adjusts itself. As that heavy jet slams onto the deck, the carrier's ballast systems automatically redistribute water. They keep the deck level, ensuring the next plane lands safely too. The ship literally thinks about its own stability, reacting before humans even notice the shift. It's like watching a giant organism breathe, adapt, and survive. Even its size, over 1,000 feet long, 250 feet wide, 20 stories tall, serves a purpose. That immense bulk isn't just for show. It's what gives it resilience. The bigger and wider the hull, the more stable it becomes. Its physics, mass resists motion. The carrier doesn't fight the waves, it absorbs them. It bends, flexes, and moves with the sea, not against it. That's how it endures storms that would destroy smaller ships. But the ocean has a way of humbling even the greatest machines. No matter how advanced our technology becomes, one massive wave, one miscalculation, one moment of imbalance, and nature reminds us who's in charge. That's why constant vigilance is key. Every system, every sensor, every person aboard is trained to maintain equilibrium, because balance isn't achieved once it's maintained every second. In many ways, the aircraft carrier represents the best of human progress. Our ability to create order in the middle of chaos, to understand forces bigger than us and use them, rather than fight them. It's not defiance, it's cooperation. Between science and nature, between human instinct and machine intelligence. Now step back for a second and think about the bigger picture. A ship that weighs more than 100,000 tons, powered by nuclear reactors, able to carry dozens of aircraft and thousands of people, moves across a fluid world that never stays still. And yet, it remains perfectly balanced. It's hard not to see a reflection there. Because in a world where everything feels unstable, where technology races ahead, where nations clash, where change never stops, maybe we're all trying to do the same thing. To stay balanced, to stay steady, no matter how rough the seas get. That's what makes the aircraft carrier so mesmerizing. It's not just a tool of war, it's a lesson in equilibrium. A reminder that strength doesn't mean rigidity. True strength means adaptability. It means bending, shifting, adjusting, and still staying upright. The carrier doesn't resist the ocean. It listens to it. It finds its rhythm within the storm. And maybe that's what we need to remember, not just as engineers, but as people. Because balance isn't a one-time achievement. It's a constant act of awareness, a delicate dance between opposing forces, between chaos and order, between ambition and humility, between progress and peace. So the next time you watch one of these giants glide across the horizon, look past the steel, past the jets, past the flags and firepower. What you're really seeing is harmony. Thousands of tons of metal, powered by the laws of physics, held together by trust, precision, and balance. And as it moves through the waves, calm, unshaken, unstoppable. Ask yourself this: if a 100,000-ton machine can find perfect balance in the most violent environment on Earth, why can't we?